Hello, welcome. My name's Eevee Bell and I work for the South Carolina Seagrant Consortium, which, has anybody heard of us before? Maybe. It doesn't hurt my feelings if you don't raise your hand. We're a really small state agency. We're located downtown, and we do a lot of marine science research and outreach and education. And my job is the outreach and education part, so I try to take relevant what's going on in the area, package it, and extend it out to the community. So K-12 students, teachers, I work a lot with teachers, and then the general public. So I do a lot of hands-on STEM education. So.
Awesome. Well, it's a pleasure to be working with you. My name is Taylor Brockman. I'm CTO at Brainpower Software, and you are part of a new product this morning. So I'm a believer in connecting K-12 students with industry. And so apprenticeship programs, internship programs, and we're designing a roadshow, effectively, we can take to different businesses around South Carolina and teach them about apprenticeship programs and find opportunities for students to actually get into business. So this morning, we're going to walk you through 3 engineering challenges and tell you a little bit more about the Seagrant's mission and how we're going to be connecting education into businesses.
And we're taking the leap of faith, since we're not working with young students. We put all the supplies on the table, so if you can restrain yourselves from playing with the things on the table. If not, we've got other tables we can put you in timeout over here. So.
You feel like these tables are designed to make you feel like you're in school.
Yes, yes. And like Taylor said, we're going to give you, this is kind of rapid fire, speed dating, if you will, with some of these engineering activities. A lot of these lead into larger concepts that we try to get across with the students. So this is just a little bit of a teaser with these challenges. So, all right.
It's all you.
All right, sounds good. Okay, do you want me to advance this way?
Yeah, I'll let you run the slides,
Okay,
and I'll stand over here out of your way.
Okay, all right. So again, my name is Eevee Bell, and I'm with South Carolina Seagrant Consortium, and I feel like I've got one of the best jobs being able to tie in my love of research with my love of teaching. So this is just going to be a couple of, again, overview of some of the projects that we're involved in and partnership with Taylor. And if you like what you see today, then please talk with us. We'd love to see about other partnerships at the end. So one of the projects that we focus on with students is the technology around buoys. And all the things that we do with Seagrant, we line up with the science standards. Teachers in grades K through 12, when they teach science, they have to hit certain standards. And so one of the big standards in 4th grade and then also in 8th grade and on up through high school is weather, and how weather or science, how it drives a lot of our weather patterns and the water cycle and other phenomena that we have going on. And so we have a project that is centered around buoys and weather buoys in particular. And so one of the things that we try to do is we talk to students about, before we start this project, we talk to them about buoys and what they are. A lot of students, especially a lot of students I work with, they may have heard the word buoy, but they may not have really connected it with something in their life. The buoy in the middle here, I like to point out with students, this buoy right here, I like to ask them to make observations on this buoy, and they'll tell me it's red, it's got a number. And then I ask them what this is right here, and a lot of times they don't know what that is. And when we zoom in, does anybody know what that is there?
Harbor seal.
It's a harbor seal, which are huge, okay? So then we start talking about, okay, does it matter if something is heavy for it to float? Does it have to be light to float? And lots of kids think yes. Does something have to be small to float? A lot of kids say yes. One of the characteristics about buoys is that they float. So they're thinking, okay, something has to be small, it has to be light. Okay, those are reasonable assumptions. So then we're like, well, how does this giant harbor seal lie on this and not sink? Think about that. So then we try to connect it to things that they may have seen. So a lot of kids have not seen a buoy like this in the water. A lot of kids haven't. And if they have, they don't remember. So then we try to tie it into things where they might remember or might have seen it before. Things like we use buoys for safety. So if you're in the water, if you dive, if you snorkel, a lot of times you have to put a diver's down flag here to alert people that there are people underwater and to be very careful. There's also throw rings. So if you go to a swimming pool or if you're on a boat, a lot of times they have a throw ring. That's also a type of buoy. It floats. It's helped keep you floating. Those folks that like to go crabbing, crab pots have a buoy on top so that they can identify where their crab pots are. You don't want to yank up somebody else's crab pot. And it also helps boaters avoid those crab pots so that they don't get their boats tangled up with running over these buoys. So we try to make those connections with the students on where they might have seen buoys. And once we do that, we then go into one of the other types of buoys that we have and trying to tie it back into the weather standard. And we've got weather buoys here. And again, what we try to bring it back and we say, okay, here's a weather buoy. What do you see? What do you see on this picture? I know it's kind of fuzzy, but what do you see on this buoy? Two guys climbing on it. So again, does something have to be small or light to float? We'll explore that. Okay. So why weather buoys are important, and we go into more in-depth in this with the students, but we have a tremendous, these are all these pretty little dots here are buoys off of our coastline. And those buoys are taking real-time data 24 hours a day, and they're looking at temperature, wind speed, current, salinity, and all these buoys right here are communicating with our meteorologists, giving us our forecasts. And if we ever do have a hurricane come through, again, they actually help predict where those patterns are going to go. So if there's a track of warm water, that might be where the hurricane tracks. And so these buoys are helping us to... They have to anchor them down. Yep. And so a lot of times, so after a hurricane, sometimes some of these will rip loose and they'll be found in another place. And it takes a tremendous amount of effort to actually bring them back and drill down. So. But they're designed to move with the currents, to move with the tides, with the waves, so they've got enough slack on that chain to be able to move up and down in extreme weather. Millions of dollars. Depending on the type of sensor units that they have they can cost millions of dollars. So that's actually a great question because that's an awesome segue because what we do is we have a student buoy project, and it was designed for elementary school students, and it's amazing to see even at a young age these students, they get these concepts of what makes something float, what makes something sink, and they may not be able to articulate it, but it's intuitive. And so we've got a curriculum where we have students actually build weather buoys. They put data instrumentation on buoys. They get to design their own structure as long as it floats. We give them a challenge. We say, okay, here are all these PVC parts and pieces. We have got a testing tub. Your buoy has to fit in this testing tub. It can't sink. It has to stay upright, and it has to be able to carry at least 12 golf balls. The reason why we do this golf ball challenge is to make sure if you're actually in the real world, you build this $1 million buoy and then you want to put $1 million worth of equipment on it, you want to make sure, even if your buoy is floating, that as soon as you put that instrumentation on, it doesn't sink. So those golf balls are to show, okay, you've got your nice buoy, let's add some weight to it and see what it does. So we do that, and the kids have a great time. We encourage, and I tell them at the outset, I don't want your buoy to work in the beginning. Why? They're not really, because a lot of kids make the same, the way they think, they're going to put, where they're going to put their instrumentation right on top. Well, when you add weight, it's going to tip over. So they learn by making modifications, and so when they put their buoy in, and it tips over, we talk through it. What modifications do you want to make? They go back, they make those modifications, and a lot of times the second time around their buoy really is great. Once we have a design, and we get all sorts of designs, we actually tie a tether to the buoy and we send it out into the water for a few hours. We've had them take real-time data, and Taylor, I'll let Taylor, do you want to show the unit now, or do you want to?
Yeah, I think we should jump into our first challenge.
Yeah. So before we build the buoy, we do a pre-activity, which is right over here. So your first activity here, we do this activity to teach students about, again, does something have to be light or small to float, okay? So we're gonna figure out whether or not that's a true assumption or not. So if you will flip that page over, this is the clay ball challenge. So there's a ball of clay in front of, right next to that tub there. And if someone will make a prediction, if you put that ball of clay in the water, do you think it'll float or sink? What do you think? Sink. Okay, let's try it out. Okay. All right, it sunk. Very good. All right.
Yay.
Now, your challenge is to use that entire ball of clay, change the shape, and make it float for at least 10 seconds. Can you do it? All right, that's your challenge.
Here comes another one. Okay, and you've got 5 minutes. Go.
I remember it's got waves could fill it. It's got a way less than water displaces, right? I think it big.
Maybe that's why it's there.
And size on it, right?
Like this.
I think.
Boat shape?
Try to make a boat out of it.
Sure. It doesn't matter. He may be onto something here or there.
Looking good.
Yeah, that
Oh,
didn't work.
oh.
Biggest possible. That's doing good.
It's got to float
Yeah.
for 10 seconds.
Think about it. So it's the opposite of this. So you lay it in like
One,
this.
two,
Your buoys like that.
3, 4, 5, 6, 7, 8, 9.
Very good.
Very good.
Very good. Very good.
Good instructions there.
I was like, I was a Star Wars shirt.
Yes, that's right. That's right.
I'm sure her husband has a few of these.
A few.
Her husband's the biggest Star Wars fan I've never met.
Oh my gosh.
Oh.
Saw the movie 3 times. And bought the soundtrack.
Should we steal it?
Yeah, I think so.
I think we
I
graciously
hear it
borrowed
works
it
pretty
from.
well.
And see, I mean, you're doing exactly what we do with students. A lot of times, right out of the gate, they look at you like you're crazy. Because if you say, if you refer to a shape with this, like I heard boat over here, then they've got that in their mind. But a lot of times, when we start this challenge, they're like, and they'll start to flatten it out, put it in the water, and then they keep making modifications, which is what we want to see.
Yeah.
Perfect. Okay. So does mass have anything to do with whether or not something floats? No, it doesn't. Now, how many of those little beads right there do you think your design can hold? So now let's add some mass to your design. You can alter it, yeah.
Don't forget about this edge right here.
Jump in.
It's definitely going to be an overflow problem.
Yeah.
That one right here was real low.
Two.
All right. There's 4.
You guys can test, and then I think, Taylor, this is the one
You
where,
can overlap.
this is how we're gonna award the prize.
Water seeping in.
Uh-oh. Oh, poor.
All right. Put one in one.
Floated with 3.
Got to put them evenly. So
Yeah, definitely.
3, 4, and right there. 5, 6, 7, 8,
Look at that.
9, 10. My prediction held true.
Done.
Oh.
12
This
is this side.
12 is going to break it.
Took a
11,
little
it'll take
bit,
11, but
but-
it won't take 12. 12 is going to break it.
Well.
Not on its side.
Oh.
13. Oh my God. 14. Here it goes, down below. Here it goes. 15.
Gotta even it out.
16.
Their ball of clay was
Holy
any
cow.
bigger than
What's a record?
Oh,
18?
I think your clay is bigger
I
than
think-
mine.
I think the 18th one did.
So 15, is that right?
18.
18.
No,
18.
17.
17 below.
Okay.
18.
Okay.
Well, racial-wise,
We can
they have more of a ball.
They have a bigger ball.
This minus 1.
Yeah.
How many there?
Awesome.
Good job. Good job. So this is
I'll
a
take
pre-activity that we do with students to get them thinking about. It's not about the weight or the size as much, but it's about the design. And so we do this, and then we give them all the buoy making PVC pipe and everything so that then they can extend this activity to building their actual buoy. So then they know if something sinks that they might want to change their design, not necessarily make it smaller. So that's our first challenge, and you guys did very well.
16.
Very
Cool.
good.
At the end, I brought my pirate booty bag. So we've got some special prizes for the winning teams. Cool.
All right.
Topic number 2, here we go. And I'm going to clear these out while Eevee starts.
All right, so so we talked about buoys and how they work with marine science research. One of the other projects that we do is we actually build underwater robots with students. And this, again, it's a nice extension from the buoy project because we use the same types of materials, but we add motors. And so remotely operated vehicles, or ROVs, if you have watched the movie Titanic, right in the beginning of that movie, they're using an ROV to explore the Titanic. ROVs are intended to be unmanned. They're tethered to a ship by a long cable, and they can move up, down, all around, and they're used for a variety of different purposes: biological exploration, repair, retrieval. So every ROV is designed for a different mission. So there's not one size fits all with your ROV. Some are very small and then they can take pictures. Others are very large if they're collecting geologic samples, for example, heavy samples. So this is a cross section. So deploying an ROV is a pretty exact business. So if you imagine you're on a ship offshore, it's pretty windy. The boat's rocking all around. You've got your ROV. You want to displace it. You want to put it in the water so that you're right over the area that you want to explore. But there are lots of factors that you've got to think about. You've got to think about things like currents. You've got to think about things like temperature. You've got to think about what landforms you're over. Again, you're talking about millions of dollars worth of equipment. So you want to do your homework first before you put this piece of equipment in the water. So this is just a cross-section of what an ROV would look like coming off of the ship. For students, I like to make the connection that not only are ROVs really cool, but if anybody likes video games, this is pretty much like a very expensive video game. But you've got a team sitting on the ship. You've got a chief scientist. You've got a pilot. You've got a joystick, just like a video game. I'm not trying to dumb it down at all, but to make that connection with students, it's a very exacting type of skill to have. So if you do have students, or if you do have kids or grandkids, and they're playing video games all the time, they might have a career on board a ship. But there is a big teamwork aspect to this. ROV teams have to be able to communicate with each other and work as a team. So that's one of those skills that we try to also get across with this project is teamwork, listening to people's ideas and working together.
That's about an underwater drone.
That's that's pretty much what it is. So these are just quick pictures. So once you, again, you've got to deploy your buoy, make sure that you're in roughly the right location that you want to be conducting your mission. You deploy it, it's still tethered up there. Then you want it to become neutrally buoyant. And what that means is, does anybody here dive? Has anybody been diving before? Okay. Neutrally buoyant, all that means is that when you get into the water, you're not hovering, you're not shooting up to the surface floating, and you're not sinking to the bottom. You're hovering kind of right in the middle of that water column. Once you're neutrally buoyant, once you get your ROV neutrally buoyant, then you can fly through the water very easily. And then you can conduct your mission. So this is one, it's obviously very, very deep. There's no light, so this ROV is pretty far down, doing some exploration down below. So ROVs are used for exploration. We've only explored 5% of our ocean, 5%. There's still a lot to explore, which is exciting. They've just discovered 10 new species right off the coast in the Atlantic. 10 new species last year, and that's just in one area. So we still have a lot to explore, which is very exciting. One of the deepest spots that still needs to be explored is the Mariana Trench, which is about 7 miles deep. If you took Mount Everest, flipped it upside down, it would be deeper than Mount Everest, just to give it some perspective. Shipwrecks and retrieval. They just discovered a World War II shipwreck off the coast of Australia. They are using ROVs to, of course, retrieve some of those artifacts, but ROVs are used for retrieval. So looking at marine archaeology, it's very important for that aspect. And then construction and repair. These are photographs from the Gulf oil spill. Tragic, very tragic, but there's a really neat video of one of the ROVs being manned to actually plug the hole of the oil leak. So ROVs have different missions depending on what the need is. So with students, we do a
Eevee,
STEM.
we have a question.
Oh yes, sorry.
Was there an ROV application in the search for that missing plane, what was it, last year out in the Pacific?
I would imagine so. I don't know for sure, but I would imagine that that's the first level of exploration, and then if you need additional, they have manned submarines that can go down as well. But the ROV is probably your best bet to do extensive exploration on that. So with our students, the STEM challenge for them is that, again, they will do another pre-activity, almost like what you did with the buoys, but they actually have to build a structure that is neutrally buoyant, and that takes a long time because it's a lot of tweaking trying to get things not to float and sink. And if we had more time, we'd probably do that with you all, but that one does take a lot of time. But we talk about neutrally buoyant, what makes something neutrally buoyant. Once we do that challenge, we then put them into teams. We talk about teamwork, and we talk about listening, drawing out their designs, thinking about what their design needs to be based on their mission. We give each of our school teams a mission, whether or not it's retrieving something off the bottom, doing biological collection, or repairing something. So each team has a mission, and so they have to build their arms. So if they're collecting something, they need to build some apparatus on their ROV to complete their mission. This project takes probably about a week or so to finish. Once they have their ROV ready to go, they have motors on them, we go to a pool and we have them complete their mission. So they get to pilot their ROV, complete their mission, and work as a team, and it's a lot of fun. So, and all the while they're learning about ocean exploration, they're learning STEM, they're working as a team, and they're being exposed to possible career paths. So as I said, a lot of homework goes into all the, before you even think about putting your ROV into the water to complete a mission, you have to do a lot of research prior, which leads us to our next challenge. And I'll turn it over to Taylor for this one.
Yes. So our next challenge, we're helping our lead scientist, Ernest, who's sporting his sea beard today. We're helping Ernest plan a mission in Charleston Harbor. And we need to inspect the new dredging operation that's been going on. And our goal this morning is to present Ernest with a recommendation on how he should run the mission next week. And we want to do that using a data set that we're going to provide. And your job as a team is to come up with a visualization and a recommendation on when you should run the mission. And we've got a couple parameters. So your tether only has 10 feet of tether. And there's bonus points for artistic creativity. So with that being said, Eevee, would you mind helping me clear the table a little bit? And we'll bring on the supplies.
All right.
Okay.
No, you're fine.
Here we go. So, the data set. And your canvases. So your goal is to prepare an executive presentation in 5 minutes or less on your recommendation for an ROV mission next week. And go.
I suppose you're not
Sure.
clearly, it's
How
probably
many minutes we had?
It's only a
How many minutes we
You
had?
have to do it when water.
Right.
5 minutes.
You get a light out, right?
Yeah, so 1400, 1600, so to me, like,
Yeah.
actually it starts 14, that's gives you
So,
2 hours. The other one from 9.
tide
That's not true though.
might
If
be
it's
a
only 10
factor.
feet long, you can't get in the water, if it's 10 foot.
And
But that's okay, 10 foot. You get more
This is
time. This one you get
military
very little
time, so
from 2 to
has to
4,
be
right? It doesn't
daylight.
quickly goes over 10
right,
feet.
because it's
Right.
Still, that might
lights.
be the better one,
Yeah.
but as you get all light,
So-
1400, 1600.
Yeah, he has.
Now,
lights.
they do it
Yeah.
today, you said Saturday, so we have daylight.
Yeah.
So you got full 2 hours to do it,
Right.
right?
Yeah.
This one is less than 2 hours.
So
Yeah.
It
somewhere in
seems
here,
that you agree with that, 10 to 14 to 16.
It only
I
has
think,
I think so, yeah.
So 14 to
then-
1600, yeah. Now, I don't know what it says. It says, oh, the seven.
Yeah, so- daylight, 10 feet of tether.
Your ROV is a tether.
This looks like
Okay,
a good time right here.
I
Right.
think.
Yeah. So,
Let's see, this is,
So
and I would say.
how do we do
so
this?
simple, but you stage it up
Is that,
already.
it's not just
At certain
a
point,
chart
you want to
displaying this information.
Execute, you know?
yeah.
So from.
So I guess we show the water depth up here,
Yeah.
and then
It seems to
daylight.
me,
Yeah.
if we have 10
I guess
feet.
so.
So let's do,
tether,
about
right? Kind of
200,
go,
is that 9,
Yeah.
1?
draw a line across at 10 feet, tether. Right?
Yeah.
Sure.
You're gonna follow.
And then
Yeah, I see
chart,
that.
Yeah.
chart this
Yeah, yeah.
And then,
up,
That makes sense.
above and below.
Yep.
You agree?
This would be the height, so.
Yep.
What point are you making?
And then 6 is 15.
This is the height of the water, right?
15 even.
And the tether,
16
but both, right?
So we have
16 is all, which is all the way up here. No, further, 16.
16, I think.
Yeah, it's almost 17. So you're
This is time,
at
right?
the top.
Yeah.
Then it goes down to 16.
So if we,
At 12.
Draw a
whoa,
line.
You know, I'm
you
good.
agree,
10
you
o'clock.
agreeing that we
Then
should
it goes
draw a
12.
horizontal line here
12.
at 10
12.
feet?
Yeah.
That's our tether?
Yeah, and then you can show your threshold. You can, they can use that as your threshold as you build out this
Yeah.
chart.
Then it drops to 10. And then 10 2. I'm going too fast, but wait.
That's all right.
It's 10 2.
And then,
And then it drops to 13 6.
So,
so,
I'm like drawing this out at 9.1, but
9 and 15 5.
you already want to start it. You start at 8.
do you agree that we can't do it when it's dark out?
Right. So if you draw all those on, it'll give you the point where you can do anything at all. You know?
Yeah.
Okay, so let's say that
Drama.
dawn happens between
Yeah,
6
good,
and
yeah.
8.
Freehand will be better.
Yeah.
So our first relevant point would be 8 o'clock, 16.8 feet.
Yeah, either way.
Do you want to,
I'm sure,
That's
I'm sure you want me to do that. Just kidding.
So now clearly,
Daylight between,
yeah, so that's our
Here's
just
a goal.
for the hell of it.
Oh, we have different
Say
colors there.
You start the mission at 1300. So we
Yeah,
You
15.
can put it in the water at 1300
So-
and then at 10.
at
1300, you
16.8,
start the-
16.8.
No, 1100.
that's the first
11.
data.
what time is sunrise?
Here about right here.
Yeah, plus or minus, no, it's 7:30.
7:30?
Stick your brush, just measure.
We'll just.
Well, we only have 5 minutes, so maybe we just eyeball
Yeah.
it, right? Let's just eyeball.
Sounds good.
It's probably 7:30. There you go.
Okay.
20.
Let's go with blue.
20 is,
19.
okay, yeah, that's good. That's good.
So we
So that's
really only
daylight-
need
daylight time.
one
Okay,
point,
so
not
now
one line.
Yeah,
when we
yeah,
take
yeah,
that,
I'm not-
we have
yeah.
daylight,
Which would be
yeah, we have to do it in this window.
Yeah.
So then we have to, since it's a 10-foot tether, we can drop it in at say 11, and it's about 11 feet.
Yeah,
so let's do-
So when does it start? We start thinking about 1 o'clock. It sounds to me
That was the
like-
data point for
For tether, right?
16.8.
Alright, so
I can make that bigger.
make a little bigger dot at the end of the
The
ruler.
tether, that's good,
Yeah,
for the distance is there.
Would be-
So we could, well, so we.
It's gotta make it really big.
Start,
Gotta fill it.
just for the hell of it. So we start
Alright,
at
sorry. Next data point is what,
11
Joe?
o'clock, and we get ready at 11 o'clock. Start at 11.
10 o'clock is at 16.
That's right about here?
No, wait a minute.
So
Wait a
here.
minute, wait a
16.
minute.
Yep.
12?
Okay.
1300, 1300.
So
Because that's
six.
when it's 1300 is
16
goes from 12
now,
to
right?
10.
Yeah.
So you can say start, and then we're gonna be, we're gonna end at 17.
Next one.
17, roughly, right there. That's how we
Time.
know, that's how we
At noon?
Okay.
Yeah, noon is
Start.
12:8.
We just put in the things, say prepare, execute, and prepare and execute.
Nice now.
And so you say, give you an hour. and
Well, you can
test.
eyeball that.
Test till you prepare. So you definitely want to put it in, get ready, fire up, it's a very short window.
That's right, we'll give them a little prepared test window.
Prepare and test, yeah, it's on Sunday, you know.
Oh, good.
Prepare and test.
Good enough, is that right here?
16 is 10.
No, you're putting it in, what time are you putting it in,
Well,
1300?
so we,
Yeah.
You should start like 11 feet there, okay?
at 16 now.
You can say 12 o'clock, prepare and test, yeah, prepare and test. Yeah.
And then 18 is.
Because we have such short window, you gotta absolutely make sure that it's worked on, that's
That's
what's
right.
working, right?
A little bit higher, somewhere right there.
13.6. Just, oh, dial it down.
It's down right here at the end.
If you really wanna get classy,
But,
you could say,
yeah,
you have
18.
14, 20, 1600, examine bottom.
I don't think we care about
14,
that, do we?
1600, 10 feet.
Yeah,
Yeah.
it's get, yeah, no, we don't, you're right.
Why don't you smooth the curve there?
Bottom exploration.
Yeah,
We take the roller to do this.
No, not.
You want it to be,
Bottom exploration.
Just follow it.
So you focus on the bottom.
you're asking the wrong person to do this.
There
You got it?
No,
Just on the bottom
Yeah.
exploration.
Yeah.
Bottom.
Where's it? That's gonna be hard to smooth.
Yeah.
Where's our black marker?
Bottom exploration.
All right. So, we don't have
Well, I guess we need a
a,
few.
we should have one.
60-second warning.
Okay, here we go.
We should have a
This is it.
point here
Got
from
pretty
which
up.
we start our smoothing,
Well, we
right?
just do the 9.
15 feet.
Yeah, just put a dot like right there. That works too.
6 o'clock, 15 feet,
All
right?
right.
15.
Oh, perfect, okay, we're done.
Okay.
Okay, that looks good. So what's your recommendation?
Let's see, we descend, we prepare and test at about noon, and we
Okay.
descend at about 1300,
Yes.
and then we get bottom exploration between 1400 and 1600.
Got 2 hours to get
Yeah,
bottom,
that's it.
and then ascend, and
Awesome.
that's it.
Hopefully I give some time on the bottom.
Was there any thought to the current, the motion of the water during the time of your operation?
None whatsoever.
No,
Sounds like a good idea, but
because we,
no.
that would have to be taken into consideration, but we didn't have the data on what the effects of the tide is. I'm not smart enough to know.
Awesome. How about you guys? What's your recommendation on when to run the exercise?
Well, we're very efficient in our operation, and we don't need a lot of time to get the ROV down there. And we know that this is slack tide here, so we're just gonna plop it in, just a few minutes before, right here, let it sink down, and we've got, so maybe at, 1:30, we plop it down, and by 2 o'clock, we're 1,400 hours, we're in position, and we enjoy about an hour worth of slack tide, and then we're done after an hour.
The other thing we didn't know is how deep it was, really. We didn't know how deep, we could guess, but probably about 40 feet, is it?
Right, yeah, in the channel's 40, 50 feet.
Okay.
Cool. Congratulations on engineering challenge number 2. All right, Eevee, we are ready to begin section 3, and I can take over that prep for you.
All right, I just needed the clear.
This is messy.
Yeah.
Oh, and if anybody wants hand sanitizers or anything like that, I've got handy wipes, just in case. Just in case. Yes. All right.
Might be our first Friday presentation with handy wipes.
Yeah, setting the bar high here.
I'm gonna be just going to drink coffee.
All right, so we wanted to end with our third challenge and just a little bit of a crash course in one of my favorite habitats. And I do a lot of my projects center around this habitat, and I love it. I could spend every day out here. But we focus a lot on one particular habitat that's starred here, which are estuaries. And I put this map up here because I think it's always a good point to remind people, no matter what age you're in, that we're all connected. And so no matter if we're down here on the coast, we are connected by this really wonderful system of rivers in our state. So everything that's happening upstream from us is going to be impacting people downstream. And so we are at the termination point of a lot of these rivers. And so if you think about that from a pollution standpoint, you know, a lot of times, a lot of the pollution that we have doesn't necessarily, it does start with where we are, but it also can come down the watershed to the termination point down here where we are.
So like a sewage pipe.
Pretty much. So you can conjure up your own image of that, but and it's not all doom and gloom, but it's something I think that it's very important that no matter where we are in the state, that we have this connection in mind. And even some of our watersheds go all the way up to North Carolina. So we've got these huge, beautiful watersheds in the Southeast and in South Carolina, and they go through a variety of different habitats. For us, down here on the coast, and this is my favorite habitat here, is a salt marsh habitat. A lot of our students live and see the salt marsh habitat every day. So whether or not they're going to school or coming home, a lot of times, this is the habitat that they have the most visual connection with. Even if they don't get out in it, they see it. As opposed to the beach. A lot of students may not see the beach because that's just not something that they go to or visit. But the salt marsh is something that they can readily identify with, even if they've never heard the term. So when I introduce the salt marsh habitat, I like to ask students, what are some words that come to mind when you think about the salt marsh habitat? Birds. Okay. What else? What other adjectives? What other things? What other words come to mind?
Swamp.
What's that?
Swamp.
Swamp. Okay. Fluff mud.
Yeah.
I'll give you some that I hear a lot. Stinky, gross, buggy, yucky. Okay. All these words, right? So my goal is to try to change their mind on that. But a lot of students have been out in the salt marsh and they sink. It's buggy, it's hot, it's gross, right? These are all the words that I hear. So what I try to do is change their mind on just how important this ecosystem is to all of us. So just a little bit, and this is I wish I had more time to really get nerdy with you, but this is just the basics of how the salt marsh and the estuary come together. And what you've got is you've got our coastal ocean. I always like to ask the audience, what ocean do we have on our coast? Atlantic, very good. I hear the Edisto Ocean a lot. I hear the Ashley Ocean a lot, the Cooper Ocean. But we have the Atlantic Ocean here, and then we have our barrier islands, Folly Beach, Sullivan's Island, estuary right here, which would be the Charleston Harbor for us, very close by. And then we've got rivers. Thinking about that watershed, these rivers are flowing down. So we've got our rivers that are coming down, freshwater rivers flowing towards the ocean. They're going to be meeting up with the saltwater ocean, okay? And the ocean is moving in and out as well with the tide. So you've got high tide, a lot more ocean water coming in. Low tide, that water is going out. And where these mix is where we get the estuary. It's where these two come together and they mix in an estuary, which for us again is the Charleston Harbor, but we've got lots of estuaries along our coastline. We also have what's called brackish water, where those two water bodies meet. So freshwater tends to be, in our rivers, tends to be from 0 to 5 parts per thousand. That's what salinity or the salt content is measured in, as parts per thousand. So usually from 0 to 5 parts per thousand, okay? Ocean water, does anybody know what ocean water might be? Okay. Ocean water roughly stays around 35 parts per thousand. It doesn't really fluctuate. You're talking about a huge amount of water. It's not going to fluctuate a whole lot, but 35 parts per thousand is typically the going rate for salt water in the ocean. And so where these mix, you get a range. It makes sense, right? You've got 0 to 5 to 35. In the middle is what brackish water is. It's going to be usually from 15 to 28 parts per thousand. Why is that range? Why do we have such a big range in the estuary? What do you think? Tides, right? So tides, so every day, we can go out 2, 3, 4 times a day, depending on the tide, and that salinity will change, okay? So animals in this area have to be extremely hardy. They have to deal with high salinities, low salinities. When it gets really, really hot, you might get a giant rainfall, and that salinity may change very, very quickly. So it's a very dynamic ecosystem. And all around that brackish water area in the estuary is where you get our salt marsh growing up. The salt marsh is comprised of a dominant plant that is one of the most salt-tolerant plants along the East Coast. It's one of the only plants that can actually tolerate salt water. It doesn't need it, but it's become adapted to it. So we're really proud of our salt marsh. We've got about 350,000 acres of salt marsh in South Carolina. In the southeast, we have about 1 million acres. So we're doing really well with the amount of salt marsh that we have, so we should be very proud. South Carolina's doing really well in some things, so that's very good. And the reason why we love the salt marshes, you can read all these. Meat and wool is probably not one of our main ecosystem services here. I love this graph. This actually came from Australia, but I love this graph. It talks about ecosystem services and why the salt marshes are important. And the main ones for people to remember are things like it is a nursery ground for a lot of the commercial species that we like to eat. So if you like shrimp, crabs, oysters, fish, their juvenile stage starts in an estuary, okay? So if we didn't have salt marshes, we would not have seafood. It is a great filter. So we talked about that pollution from within those watersheds. It has a great filtration capacity, so it's able to filter out nutrients filter out pollution that we don't want. And it's that pluff mud, when you sink in it, it's doing its job. It's acting like a sponge. So when we get things like hurricanes and big tides coming through, it actually serves as a natural buffer. So there are many others, but those are the 3 ones we like to get across with our students, that the salt marsh ecosystem really does impact and benefit our coastline. And also, we talk about diversity. So just in 10 seconds, count how many, see how many species you can identify in here. I know it's hard to see. I don't know if we can. All right, time. How many? 15, good. You've got lots of species in here. So underwater, you've got skates, sharks, red drum. You've got oysters on the bank. You've got fiddler crabs. You've got great blue herons. You've got flounder. You've got all sorts of different species. It's very diverse habitat. Even when you look out and you see that field of green, there's a lot going on underneath in the water around it. And I brought my little friend. I'll pass him around at the end, but one of the species that I absolutely love is the diamondback terrapin. This is Diamond. She's been with me 7 years, and she is the only turtle that spends its entire life in the salt marsh. So from the moment it hatches to when it lays her eggs, she stays in the salt marsh her entire life. So she's now in my office. She's not in the salt marsh, but she is in a tank in my office, and she's 7 years. I'm sorry? I do. I keep about like a low brackish, about 15 parts per thousand water. So, but I'll keep her here. She's very friendly, and I'll let you guys take a look at her at the end. But that's a picture of her in my tank. She's always looks like she's starving, but she's not. She's fine.
Is that her maximum size?
No, they'll get about this big. She probably won't get much bigger in the tank that I've got her in, but I got her from the aquarium when she was about the size of a quarter. And she was born in captivity at the aquarium, and they were worried that she might be inbred, so they did not want to release her. So anyway, I used her for education, and she's maybe not the brightest, but she's very cute. So our last challenge is looking at density. So I spent some time on that, parts per thousand, for a reason. So thinking about salty water compared to fresh water. So your challenge is that you have been out and you've been studying water. You've been in the Cooper River, you're in the Charleston Harbor, and you've been offshore. And you have taken samples because you're trying to study pollution. You're trying to figure out, what's going on in our watershed, what's going on, how polluted are our waters. So you've taken water samples from all 3 of these locations. And so you're on your way back and you hit a sandbar and labels fall off and you don't know now which sample came from which.
Uh-oh.
So you need to save your job because our lives depend on you. So what you're going to need to do, this is called Mystery Marsh Water Challenge, and we've done the first step for you. What you are going to do, and here's, and I've got the data sheets here, but you all, and both of these are exactly the same, there's no trick here, I promise. We're just 2 teams here. So I'm going to pass out the data sheet. So what you are going to want to do is look at whether or not solutions mix or solutions actually separate. And based on that, you're going to try to figure out which solution came from the ocean, which solution came from the freshwater system, and which solution came from the harbor. That is what I thought. Thank you. So what we've done just to save time is, this is the data sheet here. So we have actually put in drop 1 already for you. So what you all will need to do is put in drop 2 into each of these test tubes, so depending on the number. So test tube 1 already has the first drop, which is green, so you're going to need to put in blue and see if it actually mixes or if it separates. If it mixes, you want to put an X through it. If it actually creates a layer, you want to circle it. And based on that, once you get through all 12, you need to look and see which one came from the river, the estuary, and the ocean. And when you think that you have, and I'll set up another one, when you think you have it figured out, here's the giant test tube, and you're going to want to layer. You're going to want to layer from the freshest all the way, from the saltiest all the way to the freshest. Okay? This will make sense when you get going. Let me get, okay, so you've got all 4. Yeah.
Sheets, absolutely.
Yes.
Yep, sorry.
I guess y'all want to start on the bottom table and we'll switch halfway through.
And we've got more samples. We can give you each a.
Okay, ready, go.
We're starting on
Yeah, got it right
7
here.
through 12.
I don't know.
I'll give you red
Oh.
and green, just so you guys get your own set.
Sounds
We're
good.
supposed to be ready.
I'll be
Get your own
scribe.
set.
Oh, thanks.
Yeah, that'll make it easier.
So we got blue and test 2.
All right, I'll try.
Yep.
So,
Is that something again?
One drop.
no.
So if it mixes, then you want to put an X through it. If it actually separates and causes a distinct layer, you're going to want to circle it.
All right, so put it next to this, the whole thing, or just this?
Yeah, just put it next to the whole, like, test tube 1. There you go. Yeah.
All right.
Separates, we put it next.
I guess now we have them all. We can start at 1.
It's mixed, so,
We can start with the first one.
so I guess we,
Okay, now. So blue, how did you decide the blue was in the clear?
right?
We're doing drop
Blue
2.
Oh, one, okay, I
So
get
on
it,
test tube
okay.
1, I'm that blue.
It's not blended.
So
No,
that
it's
was.
not.
one.
It's a
So
circle.
what does that mean now? Now what do we do with that?
The layers you do is circle.
Alright,
Alright,
then
we go with layers.
All right.
Then we go blue again.
Blue,
and red
number
into
2.
yeah.
that's mixing.
Blue into red. If it mixes. That makes
Cool.
sense.
Alright, clear.
X to that, right?
Yep, next to it.
There's 2, 3, blue. Blue and the clear. That's
Mixing pretty well.
mixing. You put an extra, right?
Yep.
Okay. Clear,
It's mixing.
clear in the blue. Clear in the blue. I'd say it's mixing, wouldn't you? The mixing and separate.
It's not
Let me give it a
mixing.
little more. Let's see.
Yeah, let's
Yeah.
overdose it.
Yeah.
I don't know, that's separating, isn't it? Yeah, it's clearly separating.
Yeah.
Blue's at the bottom, so I put an extra, right?
Separating a circle.
Alright.
That's mixing.
Yeah.
Clear into red.
No, it's
That
not.
goes into
It's not.
red. That goes into red.
Okay.
It does.
You agree?
Clear and red.
I guess.
There's a line there.
Oh man, that's separating.
Yeah.
Clearly, this is not
Yeah,
clear.
So separating-
Yeah, it's a little,
Separating.
you know what, we need to
On
push that one,
surface,
so
right.
I think you're right,
Yes.
I think we can't, well,
Alright, test tube six.
yeah, there is a separation.
Clear and green.
You're right, true, dead on.
Okay.
So I know what you have there.
7?
Alright, red.
That seems to be mixing, right? That's clearly mixing. That's mixing for St. Patrick's Day. What an excellent, right?
This one, I guess.
Okay, now we're down. Test tube eight, red and declare.
Alright,
Red and
red.
declare. Red and declare. It's gonna be easy if you're gonna mix it. Sure looks like a mix, right? Alright,
Yeah,
excellent, right, if it mixes, right?
Yep.
Okay. Test tube nine, red and green.
Okay.
Red and green. Red and green.
Red again.
That's a mixer, right? Excellent mixes, right?
Mix.
Alright. So, green into blue. Blue into blue. Here it is. This is gonna be hard to tell. No, it's not.
That's separated, isn't it? Blue's the
Yeah,
bottom.
clearly it's the blue. So circle, it, right?
Circle, yeah.
So now, green and declare.
Mix that.
Green and declare, this one will be easy.
I'm gonna throw
That's how
it
it mixes. Same pattern, it's got to mix.
just to make sure. This is
Okay.
super
Correct.
level
So excellent,
first.
right?
I just wanted to make
Yep.
sure.
Okay, why not?
Yep, so
Okay,
we're on
green and
green,
red.
right?
Green into red. Oh man, that's separating.
Oh, is
easy,
it
right?
mess,
Wait,
messes
yeah,
up?
Circle, right?
Yep.
And guess what? We go 1, 2, 3, 4, 5, 7.
Alright, so what do we have here? Blue, blue and green definitely,
Blue and green.
blue and green definitely don't mix, right?
They do here, green and blue.
That's
This is
separate, right?
Okay, okay, okay. You're supposed to drop, place on the end of livestock, based on themselves, in part two, they are all four unknown samples in the straw. I don't get what that means. You know what that means?
Yes, so
It says, based on the end, one end of the large straw.
Largely
in the
mixed.
clay.
There you go.
Yeah, you have to do it.
So, guys,
Okay,
And
so
based on
now
the
we have
results,
to
in part two,
Yeah,
they
let's
are all
fix
four
it.
unknown
have a
samples.
hypothesis
Does it mean if they
about
don't mix or unknown?
whether salinity
They are all four.
or mixing or.
so
right.
these are your four
So we go
samples
on
here.
there.
So you want to layer, based on this, so based on, so if, based on the ones that separated, you might want to look at those and see how they separated out as opposed to the ones that mixed. And then,
So green is always
Wouldn't be the
above
first time
blue.
I missed something.
so,
So salinity.
And
so now what you want to do, so based on how
Green
things,
and blue are the same, green and blue are the same, right?
yeah.
so based on how things separated out, so look at the ones that actually separated out. And then you want to figure out your four colors and layer those from the saltiest
Blue's denser
to
than clear.
Yes.
the least salty.
Okay. Well,
Yes.
Where's messing this up a little bit?
So, yeah,
So
blue,
even like blue here.
and then blue is denser
White,
than
right?
green.
So,
Blue is denser than green.
alright, here we go.
put
So
that
red,
there.
I think
Alright, where's
we would
green
say
and
red
blue?
is
We
the
put those
most
together?
dense, right?
No.
That's, or the
Well,
heaviest, so
green
it would
and
fall
blue?
to the bottom.
Must have mixed.
Correct.
Yeah, mixed.
I
So
would
green
think
and
that
blue,
here,
so we-
that certainly
green
seems
blue in
to
the
be-
bottom.
where's
It
the
seems like-
idea?
well, blue and
even
green
here,
together.
it's,
Green in the
it's,
bottom. Seems like-
darker than,
Oh, maybe red
it's
on the
further down than
Red,
blue is.
hold on,
Red's always
red.
on the
It's
bottom.
heavier down
Red's
there.
the two bottoms here, no tops.
Red is on the bottom, yeah, red,
We have
green's,
here.
green's denser than,
Green and red?
or, red's
Well, then we
denser
kind of
than
already answered that
green.
question
red's on the
here.
bottom. So that tells me what.
We have red and blue anyway?
This two are the
And red
strongest
and blue
separation.
mix.
Well, this one down
Red
at
and
the
blue
bottom
and
too.
blue.
Yeah.
is really
Oh,
separated.
Red, that's red and blue, so red.
Yeah, so,
Is
so
that,
it looks like
is
green,
that
clear,
clay
blue,
or is
red.
that actually?
Yeah.
I think that may be
Probably
clay.
clay, sorry,
Yeah.
I'm not trying to eavesdrop, it's clay just to
Yeah.
get it to
Probably
stick
mixed.
in.
Gotcha.
Any questions here, is there anything that's,
Well, so
So
what's
the answer
happening
is
on
it's
this one?
red and blue are,
So at the
The
bottom.
two, red's the bottom and blue's next.
Uh,
So that's separate.
Layer.
That's separation,
Yeah.
this is
that's
separation.
separation,
Yeah.
yeah.
are the
And this
So-
one here too?
brackish.
Let's look
Clear
at
at the
Or,
bottom.
no, ocean.
Green and clear mix though. I don't know, I can't.
Yeah, I can't tell which one's above the other.
Color is 12.
On 12, let's see
I don't
which
know.
ones do
blue
you
and
have?
red, you
I don't
would
know.
know.
I can't
Green and
figure it out.
red on 12.
See, my
Oh, this is
issue
blue
is,
and
I
red.
don't know what this shows.
Oh,
Yeah,
yeah,
so-
red's,
Mix.
red's heavier than blue.
These are the four samples from the
And then
four places.
where's red and green?
The Cooper River. the Charles
So let's
River,
separate it
offshore
between-
the Oceanic
Red and
Ocean.
green is
What's that?
line.
When we just have 2 layers, 2
So I
mixed
can't
layers.
really tell much of the
You
day.
should have
actually-
4. You should have 4 distinct
And
layers.
then same thing.
All right, so
Yeah,
we
we
should
should
think
green
blue
there,
and
blue and
red
red.
is-
And what do we know about blue and red?
I
Red
think clear is
is
the
in the
lightest, because if you tell
Red is
In the bottom there, red is density green.
for all 4
Blue's
colors,
red is density
Red.
green.
4, 5,
blue,
6.
Blue
they're
is
all.
density.
Oh, yeah, yeah, red's on the bottom. Okay,
Green,
okay.
Green's
Outside
on
of
the
red,
green,
green.
ones have
Green's
blue.
on the bottom. Wait a minute, look at this. Green's green and blue.
Okay.
I think, see, this one right here is our
So-
blue and red.
Yeah.
To me, it looks like blue sunk, red sunk to the bottom, right?
Alright.
A little bit, so let's do
blue
red
one
first,
Okay.
as the
First one.
densest, right?
Yeah.
Can't even
that's
tell.
right.
Blue and green
Yeah,
is
blue
1.
Alright, what about,
Blue
there's
second.
gotta be another one in here, it's 10,
I think
10 as well. So, see, 10 makes me think green, maybe a
10
touch
is
lighter.
green and blue to reverse order.
Yeah, but you see, like, it looks like
Layering or it's mixing?
you got a little more of a tinted
We
green at the
got a
top,
little bit
blue
of
on the
light.
bottom, where
It's
here I
like-
feel like it's
it's like-
very murky.
Takes a while, but it's
It's almost
like-
like
Yeah.
blue and maybe a
It's the
little
green and clear, I
heavier.
don't know
Yeah.
which one's next.
Alright, now where are they
Green
together?
and
What
clear.
number?
Yeah.
Do we test those two?
We ready to try that out?
I believe in you guys.
Is 11?
Yeah.
Alright,
That's hard to tell.
moment of
They
truth.
mixed.
Is there clear green?
I mean, which one's in the bottom?
Yeah, I was trying to figure
If
out.
anybody needs another test tube to try out,
We did it twice. Six
I
and.
think clear on top. I can't on top. Here, let's add a little more clear to this guy. See what happens.
Uh-oh.
No, I don't.
What do you think the clear is on top?
Hope so.
That's a good green and clear. Should I have more of each, but-
Alright. The green and blue is very similar.
It's separate.
Demonstration 1, and then we'll wrap it up.
I don't know.
Yeah, there you go, now you can put it in. Alright, I think you're right.
so what do you guys think?
Oh, so now we're supposed to reduce.
Red at the
what it's
bottom.
Mm-hmm.
So now we gotta say which
from. The
one.
most dense has to be the Atlantic Ocean.
Okay, so which color would that be? Red.
Red.
Okay, so red is your Atlantic Ocean.
There's only 3 listed there though, but we have 4 colors, so.
That's true, and we're going to talk about that at
Okay.
the very end. But that's very good.
So Charleston Harbor has to be the
Yeah, it has to be a
next dense,
mixture.
and then the
of
Cooper has to be the
blue,
least,
green.
because it's up way up.
That's right.
There's a little salt in it.
So what color was Charleston? Okay, Charleston Harbor was blue. Very good. So that's your estuary.
And then the clear is Cooper River. Hopefully it's
Well,
clear.
What do you guys
Green.
think?
Green
No.
and clear, probably,
Green
because, yeah.
Green-
Upper
mhm.
Cooper River might be
Because
clear.
because remember the
Alright.
green. Well, you don't have to remember this, but sometimes rivers do have a little bit of salinity in them. So green had a little bit of salinity in it. So that was your next layer. What do you think the clear? What do you think the clear is? Tap water. And why do you think we'd want that tap water? It's as a control. As a control. So we'd want that tap water just as a control, so that clear layer should be at the top. So. Guys are smart. Guys are smart. So this gets at density. So what's your densest solution? Atlantic Ocean. So the saltier the water, the denser the water. So you saved your jobs. So that's the
Good work.
point. Good work.
Yay.
So good job, y'all. Yeah. Very good. Well, great. Well, we
sincerely
yeah.
appreciate your time this morning and
Yeah,
spending an hour with
thank
us.
you.
A lot of fun.
Yes. Thank you.
Cool. So we have a special prize. Everybody wins a prize today. They're organized on the table outside, and it's a few of my favorite things, so grab one on your way out. It ranges from coffee to full sticky Post-it notes.
Yes,
This is a brand new
great.
product. Do we have any questions or comments
Yeah.
before we wrap up today?
And my business card is out there, so if you want to chat more about anything, please reach out to me, because we're always looking for opportunities to partner, and we're very into STEM and getting our kids primed for the workforce. So
So the ask
yes,
is we've got students that need experience in industry. So if you can think of a friend or a coworker that would enjoy this type of presentation at their business, we can bring students with us and find them summer opportunities. We're just trying to connect the two dots in a very fun, casual way.
Yeah.
That's great.
Cool. Thanks.
Well,
Have a
thank you
wonderful
all.
day.
Thanks. Happy Friday. Happy St. Patrick's Day.